In this video, we're going to be taking a look at what is a projectile. Well, a projectile is any object that when you throw it or launch it is going to follow a parabolic arc. Now, what's a parabola? A parabola is kind of a fancy math term for this upside down U shape, which all projectiles have when you throw them into the air. Well, what kinds of things could be projectiles? A football could be a projectile. A bullet fired out of a gun is a projectile. A tennis ball is a projectile. And if you decide that you want to jump into a cannon, you could be a projectile. Well, then that begs the question, well, what isn't a projectile? Well, certain things that aren't projectiles. An airplane's not a projectile. Neither is a bird, nor a frisbee, because all of these things require air resistance in order to fly however they want to fly. The bird and the plane can control their own motion, and the frisbee kind of hovers on the air, so it doesn't follow that normal parabolic path, so it doesn't count as a projectile either. Well, let's take a look at the bullet example when we're talking about what is a projectile. We're going to have one person drop a bullet, and the other person's going to fire a bullet horizontally. Interesting thing about projectile motion is how fast it goes to the left or to the right doesn't have any effect on how it moves up and down. Let's zoom in on the bullet and we'll see why. So I've got two bullets. The bullet on the left is just going to be dropped, and the bullet on the right is going to be fired, and it's going to follow this normal parabolic path that a projectile follows. Well, why is it that they both fall to the ground? Because they both have a force pulling down on them, and that force for both is the force of gravity. So for the bullet that's dropped, it's just going to fall to the ground at a rate of 9.8 meters per second squared, at the rate that everything falls to the ground. Well, what about the bullet that's fired? Well, gravity isn't affected by how fast it's moving to the left or to the right. So it's going to pull this bullet down at a rate of 9.8 meters per second squared. It's following this parabolic path simply because it got pushed to the right by being fired out of the gun. So it's going to fall to the ground also at 9.8 meters per second squared, meaning that if we had a stopwatch on these two bullets, or we could slow them down, we would see them fly like this. The bullet to the right gets fired out of the gun, this bullet gets dropped, and they're both going to follow the exact same path and get to the ground at the exact same time, because of something called dimensional independence of projectile motion.